Hello everyone. In this video, I will show you how to quickly and easily generate ground control points for your photogrammetry and surveying projects. Whether you're working with drone imagery, aerial photography, or satellite data, this plugin will save you hours of manual work by automating the creation of systematically distributed control points. Let's get started. Before we dive in, ground control points or GCPs are precisely surveyed locations with known coordinates. They serve as reference points to georectify your imagery and also improve the accuracy of photogrammetric models. Alright, let's open the plugin. So you can access the GCP generator in two ways. You click the GCP generator in your toolbar, or you go to the vector menu, select GCP generator and click generate GCPs. The plugin is organized into three simple sections. Section 1, the boundary selection. This is where you choose the area where your GCPs will be generated. Section 2 is the distribution settings. Here you will decide how your points are distributed and how many you need. And the last section is output setting. This is where you choose your file format and save location. So we'll kick off by selecting our boundary layer. I'm using the reprojected Abuja boundary layer because this work will be effective if you use a reprojected coordinate system. In the distribution setting, the plugin offers two distribution types, random and even or green. You choose the random distribution type when you want your points to be spread out randomly, or you choose the even grid distribution when you want your points to be spaced evenly. So I'm going to begin with the even or grid distribution type, and I could either specify points distance or the number of points. So if I'm going to go with points distance, let's say 6,500 meters, it's going to give me, or it gave me, an estimated points in boundary of 181. So that is for the point distance. But if I'm going for number of points, let's say 1,000 points, 1,000, it's calculated a point distance of 2,717.27 meters. So unlike the even or grid distribution type, the random distribution type only offers the number of points option. So if I'm going with the random distribution, I would use the 1,000 number of points that I chose earlier and then specify my output format either in shapefile, KML, KMZ or CSV. But let's use the shapefile, and then I'm going to save my output. I was going to save it in my output path and save it as random underscore 1,000 points and save. Generate GCPs and voila. Click OK and just shift that one to the side, and then you see that our 1,000 GCPs have been generated successfully and distributed randomly as well. Okay, so I'll repeat the same process for the even or grid distribution type. I'll be using the point distance this time, 6,500 meters, and the shapefile as my output format. I'm going to browse where I'm going to save my file and then save as even underscore 6,500 meters and hit save. Generate GCPs and OK. And I'm just going to off the layer for the random distribution, and this is my even or grid distribution, 6,500 meters. So now that we have generated the points successfully, we're going to open the attributes table for the even or grade distribution. And you can see that we have our ID values, XY coordinates as well. Okay, so let's try to use another output format. We'll go with CSV in Excel file. I'm going to save it as even underscore 181 CSV, or let's just use 6,500. Yeah, that's okay, meters. And I'll save, generate GCPs, and okay. So then I'll go to where my file was saved and I'll open it. So these are our GCP points in CSV formats with our ID values and X and Y coordinates. So I hope you enjoyed this video. Until next time, bye.